Okay. So you can see here, the child has a mass of 500 Newton, and due to some extra force is jumping, and it's not due to the 700. As I said, it is due to the extra force. Additionally, he is providing 200 Newton. So what you should do here is, due to this 500, there's no problem. He's not going to jump up. Only due to this extra portion, the person is gaining a momentum. So this is your force time graph. Only due to this extra portion, the person is able to jump up. So what you have to do here is, you have to consider the area only in this part. Only this triangular section's area has to be considered. And what does the area gives us in a force time graph? What does the area provides us? That's the impulse, okay? So impulse means the change in momentum. So in this case, the person was at rest in here, but now at this point is gaining a velocity. So you can see here, let's say the mass is 50, right? 50 times V, 50 kilogram into velocity V, has to be equal to the area under this part. That is equal to my impulse. So let's say whatever answer, like 250, my velocity will be 5 meters per second. So this is how we approach the question. We did not obtain the entire area. We obtain only the area which made a change. Because of this 500 Newton, the object was unable to move. He was at rest. But due to this additional part, he is able to gain a momentum. So I obtained the moment area in this part, okay? Just a small recall of that. So let's see how this is going to connect in here. Because in here, we are having only friction. We don't have scale or whatever. We are just having only friction. So there's a certain person, actually, a certain object. The coefficient of friction is 0.2. And there's a force of F provided. There's a force of F provided. And the mass of the block is 5 kilogram. So with this information, let's get some idea. This object has a force F. And what will be the frictional force? Just say the value of it. Yes. The coefficient friction between the flow and velocity of the block at the end of tension. What was the friction? The mass is 5 kilogram. Coefficient is 0.2. So it will be 50 times of 0.2. 50 will be the weight times 0.2, which is around 10 Newton. Now see here. Now the frictional force is 10 Newton. If I provide a force like 8 Newton, will the object move? It's fine. If I provide a force of 8 Newton, will the object move?
No.
Yes. So what you should do here? If I provide a force equal to 10, it will be at the verge of moving.
Yeah.
So I should be providing a force greater than 10. So F has to be greater than 10. Only when the force is greater than 10, the object will be moving. Okay. So let's compare with this scenario. The person's weight is 500 Newton. So if he want to jump up, his feet must provide a force greater than 500 Newton. If it is equal to 500 even, he is unable to move. It has to be greater than 500 Newton. Like 700, 600. You can see these values are greater than 500. So he must provide a force greater than 500. So it is like the scenario here. I must provide a force greater than 10 Newton. Okay. So let's see what you are going to do here. So they are just giving you the force time graph. They have just given you the force time graph. 24. Okay. Now just say me, if I provide a force like 8 Newton, the object wasn't moving, right? So let's say the part is A. This part is 8 Newton. So under this section, did we gain an impulse? The force was 8 Newton. In this part, did we had an impulse? Okay, if simple, was the object moving? Yeah, no. So if the object is not moving, I don't have any impulse. M into V, velocity is 0. So I don't have any impulse here. And the most important point is, the object was initially at rest. So the change in momentum is also 0. So in this section, momentum is not achieved. What is the impulse? So what has to be the case to gain a momentum? Now, if I should gain a momentum, what should I do here?
You should apply force.
Yeah, we have to, anyways applying a force. What has to be the quality of the force?
There should be friction.
No, it has to be the same in idea. How it has to be the force? Now, whatever force, it doesn't move, right? Even if I provide 8 Newton, it wasn't moving.
Greater than 10 Newton.
Yeah, it has to be greater than 10 Newton. So that's why I said compare with this scenario. If we want to jump up, the force has to be greater than 500 Newton. So you can see these sections. So I have to provide a force greater than 10. So it has to be a part greater than 10 Newton. Now say me, is in this section, the object was moving below 10 part?
Sorry, sir, I didn't understand.
Yeah, just mark a line like this, as I did here. I obtained the area only the forces greater than 500. In here, as you say, the force has to be greater than 10 Newton. Then only the object will start to move. So what I'm asking here is, in this section, the section below 10, do I have a momentum?
Yeah.
Huh?
No.
Okay. So just get the clear. If you are confused, just say me, okay? I have to provide a force greater than 10. So below 10, any value, the object will not move. It will be as it is. Okay?
So there's no momentum.
Yeah.
So there's no momentum now.
Yeah, there's no momentum in that part. The object is rest. So you can say this section, the object is not moving. Only the section above 10, the object will start to move. Okay. So you have to deal with it impulse. Okay. So what I just did was I was comparing. So just get some ideas like that. That's the way you get experience on the past papers. Okay. Then let me just draw this graph again. So you can see only about 10, the object is moving. So as I did here, what are the forces greater than 500? Only the area of that part has to be considered. In here, it was just a triangle. I just consider area of them only. Okay. So in this part as well, the force is 10 Newton. Only above it, the object was moving. So I have to obtain the area of only them. And what will be the area providing us? Again, if I obtain the area here, what will the area provide us?
Momentum?
Yeah, change in momentum. Okay. In here, it's fine momentum because object was starting at rest. It's change in momentum. Try to find the area then. Just take around 5 minutes or right? So what was the area? Again,
120.
most of the yeah. Yeah, let's look at that. Yeah, what was your answer?
120?
Yeah, let's check that. Even I don't know. So see here, they have given you the exact information to find the area. You should know what is the time here. So if you just look at here, it is a trapezium. The height is 10. Entire part is 20. This part is 10. So this has to be 10. So this part is 10. Height is 10. You don't know what is the base length. So just say me, what is the time here? Because only in this section I'm having the area. So I should know what is the time here. What is the time?
2?
Yeah, it's 2, okay? Because for 20 it is 4. If you take even the tan theta, it's fine. 20 it is 4. For 10 it is 2, okay? The time will be 2. And this part was 12, I think. Yeah, it is 12. Yeah, it's 12, okay? So what is the gap actually here? This base length?
10.
Hmm?
10.
Yeah, 12 minus 2, it's 10. What is this part length? It is 12 minus 4.
8.
That is 8. Okay. So now let's find the area. It is half into 10 into summation of opposite sides 10 plus 8. So I'll be having, it will be 90, right? What went wrong?
No, sir, I just did it in my head. That's why.
Sorry?
I just did it in my head. That's why.
Okay. That's it. Okay, so just recap with that. In here, the time wasn't given, you have to find it. Okay. So find the impulse. The change in momentum is 90 here. Is the change in momentum. So, they're asking what is the velocity. Now the situation is really easy. I'm just erasing them. You know the momentum equation is mass into velocity. Final momentum is mass is 5 kilogram into the velocity is unknown v. Initially the object is at rest, so it is 0, which is equal. The important thing, there are so many questions with this change in momentum. Be careful with the change in direction. If it's example, the ball is colliding with the wall. After colliding, it's gonna bounce back in the opposite direction. Then you have to add them, okay? So make sure that you are gonna work with the direction vectors. In here, they are the same direction. 5 kilogram into v minus 0 is 90. V will be equal to 18 meters per second. Okay. So I hope you are finding that. It's done the same. So all okay here. And Ilma, have you covered what relativity? Because the next question is based on that. Yeah, for now, I'm just leaving that. Next class, I'm just gonna I'll just try that. So just definitely just go around then, because I think that will be an important one. Because you can see there's absolute humidity, relative humidity, the most important points. And if you're able to do that, it's fine. And yeah, what was your answer? Well, I think it was answer number 1 or whatever. That's why I think answer number 1 was that. The thing with relative humidity is you can study it whatever time, but you won't get the idea because the information is really low. You have to deal with questions. I'll just say only one point in that. Just get that idea. There's a thing called saturated pressure. That saturated pressure only varies with temperature. If you are changing the volume, it doesn't change. That will be important in this one. And another one is there's another graph as well. I'll teach you that. So that's an important point. Saturated pressure and ideal gases behavior is observed only for unsaturated pressure. we never obtain the other one, saturated one. So sometimes they might trick you with this way. They will get you the total pressure and they will giving you the saturated pressure. So you have to subtract and find the unsaturated pressure. That's somewhat important, okay? I'll just discuss in next class. Just remind me. For now, let's move. I think we tried this overtone part, right? A pipe closed at one end. Have you tried that?
The question number.
Question number G. I just read the question. A pipe closed at one end, another pipe open at both ends, have the same length. The ratio of the frequencies of nth overtone. I think I just gave it as a short note, right? If it is not, just say me. Okay. Do you want me to explain that again?
The kind of question.
Sorry. Okay, fine. Let's slightly summarize them. I just gave you some points in finding the overtone number from the harmonic numbers. So based on that one, we have to try that. Okay. Let's take a small time again. So I'm erasing this. What you have to do is every time the harmonic number is considered. If they are taking the first overtone, we have to consider the harmonic number. So let's say, if you take for the strings, first will be your fundamental frequency, then it will be 2 times your fundamental frequency, 3 times your fundamental, so on. Okay. And also another important point here is, I think I was not giving you this point. Just write it. Difference in consecutive frequencies. Difference in consecutive frequencies will provide you the fundamental frequency in a string, okay? Now, they might just give you like this. The 100 overtone frequency was 500 hertz. The 101 overtone frequency was 600 hertz. And they might ask you some basic question. What is the fundamental frequency? So you should understand, you have to get the difference between them since they are consecutive. Okay. So this is the way for the strings. And for the tubes, if it is open at one end, you can see the pattern. Fundamental frequency will be V over 4L. Then it will be 3V over 4L. Then it will be 5V over 4L. And so on. So you can see the pattern here. It is 1, 3, 5. So in here, what we do here is to find the harmonic number is 3, 5. We used to have a pattern like this. I think it is 2n plus 1. If they are saying you that it is at the first overtone, instead of n, I'm going to substitute 1. So 2 plus 1 is 3. I obtain this. For a string, it will be n plus 1. Wait. Okay, I just know you for this. For this, it is 2n plus 1. And if it is open at both ends, the pattern is V over 2L and V over 2V over 2L, 3V over 2L, like this. So the pattern will be n plus 1. N represent your overtone number. If you start adding with 1, you can find the harmonic part. So based on this, just try that question, okay? And send me the answer, I'll just check that. Be careful in one part. Here we are having V over 4L. Here we are having V over 2L. So let's move to another question. Just take this question. When two tuning forks A and B are sounded separately, that means I think the second question after this. The second question after this. When two tuning forks A and B are sounded separately, the variation of displacement in of an air molecule with time t due to sound waves generated in air are illustrated in graph. They ask you what is the beat frequency. Let's just have that. So if you look at here, there are some amount of oscillation. Here also there are some amount of oscillation. At a time they are giving it is 0.25. They are asking the beat frequency between these two. And did you try this question? Did you try this question? Now, if you have no idea to find this, just see what they're asking you here. They're asking you the beat frequency. So what is the equation for beat frequency? What is the equation for the beat frequency?
I forgot.
Beat in the sense, you have just consider only the difference, okay? If they are giving you two frequencies, from the higher one, you have to subtract the lower one. That's it. Okay. So as the first information, I'm requiring the frequency here. And I'm also requiring the frequency here. Then only I can obtain the difference between them. But they are not giving you this stuff. So how are you going to do this?
We have to get the frequencies.
Yeah, you have to obtain good. You have to obtain the frequency. How are you going to obtain it? From the graph. They have just only given you the time. Okay, so just get an idea like this. When they are giving you a graph, you can get some information. about the amplitude, about the periodic time, sometimes even the wavelength and those stuff. Okay. So if you're giving you the periodic time, you can find the frequency. So let's see how you're going to find it. Now, you should see what is the periodic time. Now you can see starting position is this way. At this position, it is this way. So I'm starting here this way. This represents one periodic time. Again, observe nicely. I'm starting from this point. It is moving quite downward. And it is also moving upward. And now you can see they are at the same position, but with a different time lapse. That is known as a periodic time. So in the first one, see how many periodic times are there. In that 0.25 seconds. In the second one, see how many periodic times are there in the 0.25 seconds. I think the recording is going to cancel off. Let's see. Just try that.